Hello bachcho, let's read the question. The question says, irradiating the metal surface successively by radiations of wavelength 3000 Armstrong and 5400 Armstrong, it is found that the maximum velocities of electrons are in the ratio 2:1. We need to find the work function of the metal surface in milli electron volt. So इस question में we can use Einstein photoelectric equation to get the value of work function. So Einstein photoelectric equations before that एक important condition यहाँ पे given है, that is v1 by v2. अगर हम velocities मान ले, when v1 is velocity when 3000 Armstrong wavelength use कर रहे हैं, and v2 is the velocity of electron when we are using 5400 Armstrong wavelength. So यहाँ पे ये ratio दिया है 2. So from this we can say v1 will be equals to twice of v2. So ये relation we will use further. Now we can write by Einstein photoelectric equation, we can say by Einstein photoelectric equation, it says h nu is equals to work function plus of kinetic energy. So from this we can say the value of work function, from here we can write this as, or we can say half mv square will be equals to h nu minus of phi. Alright, so यही equation अब हम आगे use करेंगे to get the value of phi, that is work function. So now what we can write from here is, we can say for the first case जब हम wavelength use कर रहे हैं 3000, so we can say this equation can be written as half m v1 square, and that is equals to nu की जगह हम लिख सकते हैं, that is frequency की जगह हम लिख सकते हैं c by lambda 1 minus of phi. Phi is dependent on material property, so phi will remain the same. So second case में हम लिख सकते हैं half m v2 square is equals to hc over lambda 2 minus of phi. So इन दोनों equations को, that is equation 1 and equation 2, अगर हम दोनों equations को divide करें, so we will get v1 by v2 the whole square, and that is equals to hc by lambda 1 minus phi divided by hc by lambda 2 minus phi. Alright, so v1 की जगह हम twice of v2 substitute करेंगे, so equation will become 4 is equals to, और यहाँ पे we can just multiply the things, so we can write hc by lambda 2 minus of phi, और यहाँ बचेगा हमारे पास hc by lambda 1 minus phi. So we can take the wavelength वाले term को हम one side shift करते हैं and rest of the term on one side. So what we will left with is hc common भी लिया जा सकता है, so we are left with this, और यहाँ जो बचेगा वो बचेगा 3 phi. Alright, so this is what the values we are getting, और यहाँ से हम we can calculate the value of phi easily. So Planck constant की value we will substitute it. So now the substitution part is there. So h is 6.6 10 raised to minus 34, speed of light is 3 into 10 raised to 8, dividing by, यहाँ पे lambdas are given in Armstrong, so Armstrong को convert करेंगे मीटर में, so 10 raised to minus 10 भी common ले लेते हैं out, और this value of 3 will come over here, and यहाँ पे जो terms बचेंगे वो होंगे 4 by lambda 2 is 5400 minus of 1 over 3000, that is equals to 5. 3 and 3 will get cancelled out, so यहाँ पे बचा 6.6 into 10 raised to minus 16 into, this will be, here we can write this as 12,000 minus of 5400 divided by, this can be written as 5400 into 3000. Alright, so this is equals to 5. So from here we can say the answer final comes out to be 6.6 into 10 raised to minus 16 into, यहाँ पे ये value हो जाएगी, we can write this as, so this value will be 6600 divided by, this will be 162 into 10 raised to 5, and that is equals to 5. सो फाइनली हम बोल सकते हैं यहाँ पे द वैल्यू ऑफ फाई विल बी इक्वल्स टू दिस विल बी फाइनल रिजल्ट जो हमें मिलेगा वो होगा 10⁻⁻19. Alright, and here it can be written as 2.69 joules. So ये value हमें joules में मिली, but we are interested in finding it in milli electron volt. So first we have to convert it into electron volt. So we can take it over this side. So यहाँ पे we can say therefore phi will be equals to 2.69 into 10⁻⁻19 divided by 1.6 into 10⁻⁻19. So यहाँ से ये cancelled and the value of phi comes out to be 1.68 इलेक्ट्रॉन वोल्ट. लेकिन हमें आंसर चाहिए मिली इलेक्ट्रॉन वोल्ट में, सो वी कैन राइट देयरफॉर फाइनल आंसर जो हमें मिलेगा 5 विल बी इक्वल्स टू, हमें जस्ट इसे 1000 से मल्टीप्लाई करना होगा, सो वी विल गेट द आंसर एज 1680 मिली इलेक्ट्रॉन वोल्ट. सो दिस इज द आंसर टू द क्वेश्चन एंड वी कैन से यहाँ पे जो वैल्यू आई है दिस इज द फाइनल आंसर, दैट इज the work function in milli electron volt. I hope you understood it well. All the best.